students, today's agenda is to check homework will be graphing rational functions, and you will be able to do 7.5. Today, students will be able to graph rational functions with removable discontinuities. And what that means is that sometimes there are going to be holes in our rational function graphs, and so that's what we're going to be covering today. And these are the three different examples that we'll be graphing in this lesson. So if you need to do one where you have to factor first, or you can start looking at the first ones, that way you understand where the holes come from. And what I will be doing is graphing our rational function first by finding some of the components like the y-intercept, the x-intercept, the vertical asymptote, and the horizontal asymptote, and also including the removable discontinuity. After that, I will include a table to find some other points so that your graph can be more specific.
I love you for infinity.
Infinity. Positive infinity.
Infinity.
I should put that at the end instead.
Yeah.
And after I do that, I'll include a table just so that you can see how to graph both ways, and also see where the graph is actually going through. Okay, so when you have factors like this already, you can see that y is equals to x plus 2 times x plus 3 all over factors x minus 2 times x plus 3. The first thing that we're going to do is cancel whatever is the same. So x plus 3 divided by x plus 3 becomes 1. And so what am I left with? It's y equals x plus 2 divided by x minus 2. So those are, that's the simplified rational. And so the first thing that you want to do is to find the removable discontinuity. Okay, so what are we going to do? These that we cancel, okay, removable, a hole, okay? It's going to be empty at that point. And so what you're going to do is get this that you cancel, x plus 3, equal it to 0. I cancel by subtracting, and I get x equals 0 minus 3 is negative 3. So the value for x will be negative 3. And now I have to find the value for y. How do I find the value for y? Well, what I'm going to do is just replace this negative 3 into whatever I have here. And so y is equals to negative 3 instead of x plus 2 over negative 3 minus 2. And so that's going to be negative 3 plus 2 is negative 1 over negative 3 minus 2 is negative 5. Negative divided by negative becomes positive 1/5. And 1 divided by 5 is 0.2. So you can leave it, if you want, as a fraction or as a decimal. Whichever you prefer, that's fine. I usually prefer to how many parts to break it into and how many I move. Okay, I'll explain that in a little bit. So that's going to be the whole in my graph. Okay, it's that right there. It's the removable discontinuity. And so now I'm going to start looking for using this right here. This is the simplified rational function. That's what I'm going to use to start finding my y-intercept, my x-intercept, the vertical and horizontal asymptote. Okay, so the y-intercept, when we're looking for the y-intercept, x equals 0. And so y is equals to 0 plus 2 over 0 minus 2. All I'm doing is replacing x by 0. And so that's 0 plus 2 is 2. 0 minus 2 is negative 2. And 2 divided by negative 2 is negative 1. So my y-intercept is x is 0, y is negative 1. Okay, I have another piece of information. For my x-intercept, y will be 0. Remember that for the intercepts, the opposite is 0. So I'm going to replace that y by 0. And then just start writing x plus 2 over x minus 2. Then I'm going to cancel. If I'm dividing, the opposite is to multiply by x minus 2 on both sides. These cancel, and I get x plus 2 equals anything multiplied by 0 is 0. And so now, to solve for x, if I'm adding 2, the opposite is to subtract 2. This cancels, and x equals 0 minus 2, negative 2. So my x-intercept, x is negative 2, y is 0, because we replaced y by 0. Now I'm going to look for the horizontal asymptote, which also tells me the end behavior, okay? And behavior. Okay, so to find the horizontal asymptote, these are the rules. If the degree of the denominator is greater than the one in the numerator, the horizontal asymptote is always y equals 0. So your asymptote will be like that, right on the x-axis. And we represent it by a dotted line. Now, if the degree of the denominator is less than the numerator, there is no horizontal asymptote. So that means that it will always have a line that crosses through every value, okay? And if the degree of the denominator is equal to the degree in the numerator, meaning the exponents of both variables are the same, to find the horizontal asymptote, you have to divide the coefficients. In this case, 3 divided by 1. So let's look at this one. Since the degree is 1 and 1 in there, they're the same. That means that I have to divide the coefficients. And in the coefficients, we can see that we have a 1 and a 1. And 1 divided by 1 is 1. So what is the horizontal asymptote? It's going to be 1. Okay, so again, it's because it's x to the first power divided by x to the first power. But what we look at is the coefficients, which is 1 divided by 1. So 1 divided by 1 is equals to 1. Okay, that's my horizontal asymptote. And the last piece of information that we need is the vertical asymptote. For the vertical asymptote, what you're going to get is whatever is in the denominator, x minus 2, and solve for that. So x minus 2 equals 0, equals 0, and then solve for x. If I have minus 2, I'm going to add 2. And so x is equals to 0 plus 2 is 2. And that just means that x cannot be equals to 2 because we can have 0 in the denominator. Otherwise, that's undefined. Okay? Okay, so now that we have all of that information, we can do our very rough graph. The first thing that you want to locate is your horizontal asymptote and your vertical asymptote. So the horizontal asymptote is at 1. Horizontal means going like the horizon, and it's at 1, so it's just going to be right there at 1. Okay, it means that our graph will not cross in there. The other one, the vertical asymptote, is at 2. So 1, 2, it's right here. And then if you notice, the first thing that we need to locate is, can't see it, the removable will be, because we removed this, we go to that point -3 1/5. So let's go back. -3 1/5. -3 is right here. -1, -2, -3. And then 1/5, it just means cut that into 5 pieces and just jump one. That hole is going to be right there. So you're going to open a dot in there. You're going to create a tiny circle, but it's going to be open. What does that mean? Our graph is going to go through there, but that point is not part of the solutions. Why? Because we removed it in here. Now what I'm going to do is to use a pencil to draw my graph, because I do want to create a table and find other points that are going to be in there and see how close I am. So the other part that I need is 0, -1 for my y-intercept, and this is just to guide me. Where in here will my graph be? They are diagonal to each other, so if I have it in here, and I notice that this is part of the graph, so one is going to be in here, the other one will be here, and so let's look at our intercepts. For the y-intercept, it's at 0, -1. 0 is right here, -1 is right here. So that's one of my points. And then the x-intercept is at -2, 0. -2, 0 is right there. What does that mean? That means that my graph is going to go something like that, but then it touches at that point, and then there is a hole in there, and it just continues where my graph will approach this asymptote, but it will never touch it. Same here. The vertical asymptote, it will go close to it, approach it, but never touch it, okay? Let me erase this part right here. And of course, I'll erase it all once we find the table values. That's going to be easier. So if I have my graph like this, that means that I'm going to have another graph where it's going to go something like that, where again this approaches the vertical asymptote and this approaches right here. It's never going beyond that. Okay, to create a table, this is how I usually choose my values. So I look at my vertical asymptote, which is at 2, and I put that right in the middle, and then I find 3 other values on the right and 3 values on the left, but I usually get one that is a fraction and then a whole, 2 whole. It's up to you of how much you want to do. I would do 2 1/2. So I have 2, which is the asymptote, and that's actually undefined. Remember that it doesn't go through there. 3, 4, and then on the other side of that asymptote, I take away 1/2, so it would be 1 1/2, 1 1/2. So it would be in here, and then to see where it goes actually, and then 1, and then maybe 0. Especially now that we have other points that we already can guide ourselves with for the x-intercept and also that removable discontinuity accent. Okay, so y is equals to x plus 2 divided by x minus 2. I'm just getting the simplified form of that fractional expression or function that we have, and let's start working with it. So y is equals to, we replace the x by 4 plus 2 divided by 4 minus 2. 4 plus 2 is 6, 4 minus 2 is 2, and 6 divided by 2 is 3. So that's the value right here. I'll use a different color so that they don't get confused. So y is equals to 3 plus 2 divided by 3 minus 2. So all I'm doing is replacing these values that we chose in x. 3 plus 2 is 5. 3 minus 2 is 1. And so that's equals to 5. Then we have y is equals to 2 1/2 plus 2. 2 1/2 minus 2. 2 1/2 plus 2 is 4 1/2. And 2 1/2 minus 2. So you're taking away the 2 and you're left with 1/2. And here it says how many halves going to 4 and 1/2? Well, there are 8 halves in 4, and one more half is 9. You can use decimals. You know that 4 and a half is just means 4.5 divided by 1/2 divided by 0.5 equals 9. Okay. Okay, for the next one, you have y is equals to 1 and 1/2, or 1.5 if you prefer, plus 2 over 1 and 1/2 minus 2. So that you add the whole numbers, which is 3 and 1/2. And then in here, 1 and 1/2 minus 2, well, it's like 1.5 minus $2. That means that you still owe 0.5 or negative 1/2. Okay. Or the other way to see it is you have 2 cakes, subtract, but then leave the greater sign. Okay. 2 minus 1.5, you are left with 1/2, but because the negative is bigger, then you put the negative. Now in here, positive divided by negative becomes negative. How many halves go into 3 and 1/2? It's 7. Okay, let me show you. The other way to do it is 3.5 divided by 1/2 is the same as 0.5, but you're going to put the negative. This is the symbol for negative. Sometimes they have a negative between a parentheses, and you usually put it afterwards. Some calculators, first you put the sign and then the number, but in most of them, you will put the number first, and then you add the sign. And finally, equal -7. For the next one, you have y is equals to 1 plus 2 and 1 minus 2. 1 plus 2 is 3. 1 minus 2 is -1. And 3 divided by -1 is -3. And finally, y is equals to 0 plus 2 divided by 0 minus 2 equals 2 divided by -2. We already saw this one with when for the y-intercept, x was 0. 2 divided by -2 is -1. Okay, now that we have the values, now we can use pen. Okay, so we have 4, 3. So 1, 2, 3, 4. 3 is 1, 2, 3 is right here. Yep, right here. For the next one, 3, 5. 1, 2, 3. And then 1, 2, 3, 4, 5, right here. And 2.5, 9. 2 and 1/2, and then you put 9 is way up there, somewhere around here. Okay, the 5, because if you put, let's see, 5 plus 2 is 7. 5 minus 2 is 3. 7 divided by 3. So for 5, it will be 2 and 1/3. So 1, 2 and 1/3, somewhere in there. Okay, so your graph is actually up a little more than what we had it. And so these are more specific points. Okay. On the other side, so 1.5, -7 will be 1, 2, 3, 4, 5, 6, 7, somewhere around here. 7, somewhere around here. The other one is at 1, -3. So 1, -3, right there. 0, -1. 0, -1 is right there. So my graph will actually go, for that one we were a little closer, but still a little off as well. Now in here we have our y-intercept. It goes through my x-intercept as well, and it goes to the discontinuity, but we don't include that. And then approaching that, and Okay, so again, don't forget to leave this point open. It means that the line goes through every other point except that point right there. So this is our actual graph. Notice how the sketch, once we don't have some of the information, is a little off, and so that's why I wanted to use pencil. Okay, this is number 2. Again, the first thing that you want to do is see if you can simplify that expression, and I noticed that x plus 2, even though they're not aligned right on top of each other, they are factors both in the numerator and denominator, so they cancel each other because anything divided by itself is always equals to 1. And so the first thing we need to do is rewrite it in the simplified form, which is x minus 1 divided by x minus 3. And so the second thing that you want to do is to find that whole or removable discontinuity. And so it's going to be exactly at that point when that is equals to 0. So x plus 2 equals 0. We solve for x by subtracting, and so x equals 0 minus 2 is negative 2. So that's my value of x. Now to find y, I'm going to substitute in the simplified function, rational function, and you want to substitute x with negative 2. So y is equals to negative 2 minus 1 over negative 2 minus 3. Negative 2 minus 1 is negative 3. Negative 2 minus 3 is negative 5. And so negative divided by negative becomes positive 3/5. When I have fifths, I think of $20 bills. Why? Because 5 $20 bills make 100. What do $3 bills make? It's $60. So this is 0.6 or 0.60. If you notice in here, 3 divided by 5, you get 0.6. So to remember fifths, I think of $20 bills. Okay, so when x is negative 2, my y value will be 0.6 or 3/5. And that's going to be where my whole will be in my graph. Okay, so if you don't need to do the table for the y-intercept, x will be 0. So I replace x in there with 0. Y equals 0 minus 1 over 0 minus 3. 0 minus 1 is negative 1. 0 minus 3 is negative 3. Negative divided by negative is positive 1/3. So my y-intercept is 0, 1/3. For the x-intercept, y will be equals to 0. So 0 is equals to x minus 1 over x minus 3. If I'm dividing by x minus 3, I multiply both sides by x minus 3. This cancels. You get x minus 1 equals anything multiplied times 0 is 0. And so if I'm subtracting 1, I cancel by adding 1. And so x equals 0 plus 1, 1. So my x-intercept is 1, 0. 1, 0. Now the horizontal asymptote, which it just tells me what the end behavior will be, right? What value of y does it approach when x is going to the infinite positive and the negative infinite, okay? So let's look at those rules. And for this one, again, the degree is 1 and 1, right? You have x. We're just looking at the value of x. So it's going to be x to the first power divided by x to the first power. But in reality, what we'll be dividing is not the degree, but the coefficients. And I'm just sharing, in this case, it's going to be the same thing, but it's 1 divided by 1. Why? Because the rule says that if the degree in the denominator is equal to the degree in the numerator, so we look at the degrees, then we have to divide the coefficients. Y is equals to the coefficient of the numerator divided by the coefficient in the denominator. Okay, so it's in the same order. This divided by this one. And here 1 divided by 1 equals 1. So my asymptote, my horizontal asymptote is a positive 1. For my vertical asymptote, remember that we get whatever is in the denominator. We get whatever is in the denominator, x minus 3. X minus 3 equal that to 0. And so if I'm subtracting 3, the opposite is to add 3. X equals 0 plus 3 is 3. And so it just means that the graph will not cross because we cannot have a denominator 0. Okay, that will be undefined. And that's why when I choose the values on the table, I put undefined for that vertical asymptote. Why? Because we cannot have 0 in the denominator. By putting it into a 0, that's undefined. Anything divided by 0, the answer will be undefined. In the calculator, it's actually error. It says error because it's not possible. Okay, we're ready to graph. Let's find that hole that we have in here. This is the removable discontinuity. So the removable discontinuity will be at negative 2.6. So let's go find that. Negative 2.6. Somewhere in there. So somewhere in there, it should be a little higher. You're cutting into 5 pieces and you get 3 of those. So somewhere in here, I put it way too low, so I erased it right now. Okay, so that's where my graph will go. It will cross through there, but it's empty in there. It does not cross that point. Okay, so let's find the x and y intercept. 0 right here, 1/3 is around there, so that's one of my points. Then for the x-intercept is 1, 0, so 1, 0 is right there. And I forgot to include the horizontal asymptote. I think this makes it easier actually. The horizontal asymptote is 1 right there, and the vertical asymptote is at 3, positive 3, so it's right there. I'll just create my graph. So we know that it goes through here, that it approaches this asymptote, but it will never cross it. It'll go through there. That's empty, so that's a hole in my graph. And you have something like this, okay? And then these mirrors in here, it's actually a rotation in reality. And so that means that it's going to go, like I could even just find some points that will match, but I'm not going to do that right now. Once we find a table, then I can create those. If you don't need to do the table, you can just forward and that's all you need to do. Okay, for those who will decide to stay and want to find out how to find specific values, you look at the vertical asymptote and you choose the value and put it in the middle. Okay, after that you just put 3.5 or 3.5. Let me use one with decimal so that you can practice with that. 4, 5, and then on the other side is 2.5, 2, and 1. And of course you can choose other values, but I'll go with this ones. So again, let me rewrite the equation, simplified already. X minus 1, x minus 3, and so I start y is equals 2, replace the x, so 5 minus 1 over 5 minus 3. 5 minus 1 is 4, 5 minus 3 is 2, and 4 divided by 2 is 2. For the next one, y is equals to 4 minus 1 over 4 minus 3. 4 minus 1 is 3. 4 minus 3 is 1, and 3 divided by 1 is 3. For the next one, y is equals to 3.5 minus 1, 3.5 minus 3. 3.5 minus 1 is 2.5. 3.5 minus 3 is 0.5. And it just means how many halves are in 2 cakes and a half. Okay, so it's 5. Just put 2.5 divided by 0.5 equals, and you get 5. For this one, let me show you why. This is my vertical asymptote. And so y is equal to 3 minus 1 over 3 minus 3. 3 minus 1 is 2. 3 minus 3 is 0. And look at what you get in the calculator when you divide 0 to any number divided by 0. 2 divided by 0, it says error. Error, in here we just put it as undefined. That's why I put that in the other one. Okay? It just means that my graph will never cross that asymptote. Okay, so 2.5 is equals to 2.5 minus 1 over 2.5 minus 3. 2.5 minus 1 is 1.5. 2.5 minus 3 is negative 0.5. 2.5 minus 3. 2.5 minus 3 equals negative 0.5. Positive divided by negative is negative 0.5. How many 0.5s do we have in 1.5? 3 of them. Okay, so it's negative 3. For the next one, y is equals to 2 minus 1 over 2 minus 3. 2 minus 1 is 1. 2 minus 3 is negative 1. And positive divided by negative is negative 1. So, negative 1. For the last one, y is equals to 1 minus 1 over 1 minus 3. 1 minus 1 is 0. 1 minus 3 is negative 2. And 0 divided by anything is always 0. Okay? So if it's in the denominator, that will be undefined. But if it's on top, I said when 0 is on top, 0 wins. Okay? And now we're ready to locate those points in our graph and see how close we were. So 5, 2. 1, 2, 3, 4, 5. 1, 2. Right there. For the next one is 4, 3. So 4, 3 is right there. 3.55. 3.55 is right there. We were close, but not close enough. So let's erase that part. And you can make it nicer by going over those lines. Again, it just means that this will never cross the asymptotes. That's why those asymptotes are right there. Okay, on the other side, you have 2.5, negative 3. So 2.5, negative 3 will be negative 1, negative 2, negative 3. The other one is 2, negative 1, 2, negative 1, almost, and 1, 0. 1, 0 is right there. So this one is a little closer, and I think maybe I was guiding myself with the x and y intercept, and that's why it helped a little a little bit more. So you can see that when you have those values on the table, those help more than if you just have the x and y intercepts. But as your professor, your teacher, if they want you to have more points, or if the x, y intercept and the asymptotes are enough, of course, finding the removable discontinuity, which will give you the hole in that graph, okay? So there it is.